Today we're going to talk about two-sided equations and multi-step equations and how to solve them. Please pause the video to take time to set up your own Cornell notes and resume when you're ready. So the first main idea is two-sided equations. So what do I mean by two-sided equations? Well, two-sided equations have a variable term on both sides of the equal sign. As an example, 3x minus 5 equals 6x plus 10. Notice on the left-hand side, there is a term with a variable. On the right-hand side, there's another term with that same variable. There's a 3x on the left, and there's 6x on the right side of the equal sign. That makes this two-sided. The numbers, -5 and +10, are what we call constant terms. They're constant because they don't change. Variables are the ones that can change based on the value of x. When we're solving two-sided equations, we can really break it down into 3 steps. You first want to start by moving the variable term to one side. You can move them to the left or to the right, it does not matter. But once you've made that decision, the second step is you move the constant terms, or those numbers, to the other side, the opposite side that you moved the variables to. Think of it as splitting up the variables and the constant terms. Our third and final step is to divide both sides to get the variable by itself. Let's see what that looks like on this example. So we had 3x minus 5 equals 6x plus 10. If I wanted to move something, I can move a term by adding it or subtracting it, depending on what's going to make it zero out. If I wanted to move 3x to the other side, because it's a positive 3x, I would need to subtract 3x from both sides, making sure to line up the like terms. That's going to leave me with -5 equals 3x plus 10. Notice when we simplified, 3x minus 3x was 0, and 6x minus 3x was 3x. So step 2 says to move the constant terms or the numbers to the other side. Since we move the variable term to the right, we want to take that constant term of plus 10 or positive 10 and move it to the other side using inverse operations. So to undo or reverse a plus 10, we minus 10. 10 minus 10 is 0, and we simplify the rest of the equation. We get -15 equals 3x. Step number 3 is to divide. Since we want to undo the multiplication of 3, we divide by 3 on each side. That's going to leave us with our answer, x equals -5. And that's how we solve two-sided equations when there's variables on each side. Now it does get a little bit more complicated than that. There are also equations called multi-step equations. Multi-step equations are equations that contain more than 2 steps to solve. It might include distributing, it might include combining like terms, or it could be considered two-sided equations, because as we saw, it took 3 steps to solve. Here's an example of another two-sided equation that I'd like you to try. So at this time, I want you to pause the video, try it for yourself, and once you've solved it, check back to see how you did. All right, when I solved, I got x equals negative 14. Hopefully you got the same thing. If your work doesn't look the same on the inside of the problem or the middle of the problem, that's okay. When you have more than one step, sometimes it's okay to do things in a different order, especially with two-sided equations. You'll notice on this one, I decided to subtract 2x from both sides as a way of moving the variables to the left. Since I moved the variable terms to the left-hand side, I decided I wanted to move the constant terms then to the right-hand side. So I wanted to undo the plus 5. I subtracted 5 from both sides to get x by itself. So there's more than one way to show work and to get those variables and constant terms separated so that we can solve for x. And it's okay if it looks different. Here's another multi-step equation. Notice we have parentheses. Well, if we wanted to try to simplify this, we can't add x and 5 together because they're not like terms. We could multiply 4 times x plus 5. We'd be using the distributive property. But I wonder, could we, instead of distributing the 4, undo this multiplication? Well, let's see what that would look like. If I wanted to undo multiplication, I would divide. And while that works on the left-hand side to divide, 15 is not divisible by 4. I'd be getting decimal answers when I do that. So instead, let's distribute. And we can maybe avoid decimals. So we start by multiplying 4 times x and 4 times 5. That gives us 4x plus 20 equals 15. We now have a two-step equation. I know it's a two-step equation because I see two operations to undo. So thinking back to last week, remember to use SADMA. Undo the additions or subtractions first. So to undo a plus 20, I want to take away 20 from each side. That's going to leave me with 4x equals negative 5. Next, I want to undo that multiplication. So I divide by 4 on each side. And I'll get x equals, it looks like we're still going to end up with a decimal answer. And you know what? That's okay. If we divide that out on the calculator, we get negative 1.25. If I didn't want to divide that out on a calculator, I could leave that answer as an improper fraction, negative 5/4. As long as I reduce the fraction, it's okay to leave it that way. Either answer is fine. You don't need to do both. Question number 3. We're starting to see the problem build a little bit more and more each time. This one has a few more steps that we're going to end up having to do. Just like in the last problem, we see that we can distribute as one of our steps. So we're going to start by distributing. So we multiply negative 2 times 3x is negative 6x. Negative 2 times a negative 1 is plus 2. Because when you multiply a negative times another negative, you get a positive answer. Next, we bring down the minus 3 and equals 18. So our first step was the distributive property. Next, we look at our example and we see there are two terms that are considered like terms. They have the same variable parts because they don't have variables. Those are constant terms that we can combine. When I combine a 2 and a negative 3, I just can take 2 minus 3. I get negative 1. So my equation simplifies to negative 6x minus 1 equals 18. Now that we've simplified the left-hand side, we're ready to finish solving. I want to undo the subtraction first So I add 1 to both sides. That's going to give me negative 6x equals 19. Finally, I can divide to undo the multiplication. I divide by negative 6 because I'm trying to turn that into a positive x. And on the other side, I know I can't divide 19 by 6 because I'd get a decimal. It's actually a repeating decimal. So in this case, I'm definitely going to leave my answer as an improper fraction. And since 19/6 cannot be reduced, I can leave it like that. All right, our final example. This one has parentheses on both sides of the equation. We're going to need to distribute on both sides. On the left-hand side, we start by multiplying. 2 times negative 3x is negative 6x. Then we multiply 2 times positive 4, and we get positive 8. On the right-hand side, we're going to distribute the negative 5. Negative 5 times x is negative 5x. And a negative 5 times a negative 8 is a positive 40. If you feel like you're up to it, this would be a good time to pause the video and try to finish solving this two-sided equation on your own. So next I want to try to move the variables to the same side. It doesn't matter if I move them to the left or to the right. I just need to make sure that I'm using inverse operations. Both happen to be negative coefficients in front of the variable term. So I'm just going to move the variables to the left. I want to undo the negative 5x, so I add 5x on each side. That's going to leave me with negative 1x. Bring down the plus 8. I check when I combine negative 5x and positive 5x, it adds up to 0 because they're opposites. And then I bring down the positive 40. So I move the variable terms to the left. That means I want to move the constant numbers to the right. I want to undo a plus 8. So I subtract 8 from both sides. That's going to leave me with negative 1x equals 32. My final step is to divide. Since I want to undo a multiplication of negative 1, I divide by negative 1 on both sides, and I get x equals negative 32 as my solution. It's a lot of steps, but we can do this. That's the end of our notes for today. But what I'd like you to do for your summary, instead of answering the essential question, I'd like you to explain the steps we used to solve example number 4. There are some sentence starters to help you to write first we, then we, next we, and finally, what did we do? You'll also find your assignment posted in Schoology, titled Unit 0, Day 4. Let me know if you have any questions.